All right, but without further ado, the man, the myth, the legend, Brian Grant.
Ah, Thank you, Tina. I am at least one of those three things. Uh, I think at least one. So I guess I'm not entirely sure. So I think I may have just created this presentation for the title, and then I wrote that and then built everything around it because I like puns. Those are good. So what we're going to be focusing on today is an introduction to DAX. Brian, you've introduced DAX like 80 trillion times. When are you going to get it right? I don't know, but we're going to try it again tonight. So let's dig into it, shall we? Let's dig in. So I'm going to start today talking about DAX aggregation functions. In fact, that's all we're going to talk about today, right? So the good news about aggregation functions in DAX is that they're pretty easy to work with. So they're pretty simple. They're very much like Excel, right? There's like sum functions, max functions, averages, pretty simple stuff. All you do is you type in the name of the aggregation that you want, whether you want a sum, a max, or an average, and then in parentheses, you type in the name of the column that you want to aggregate. So if you want to aggregate the amount column in the sales table, you type in sales, then the little square brackets and amount. If you want to sum up the quantity column in the sales table, you do sum, sales, and the little square brackets, quantity column, right? Uh, Folks familiar with Excel are probably more used to A1 things where it says A1 colon, A200, something like that. Although if you've worked with Excel tables before, they use this exact same kind of syntax here. So it's really not that tricky, right? Now, that's the good news. The bad news is that understanding how they work is a smidge trickier, right? I don't want to call it really, really difficult, but trying to read paragraphs of how it works can be very, very confusing. So that's what I'm going to try and help you through tonight, right? In this presentation, we're going to look at how these simple aggregation functions work, as well as the basics of filtering in terms of slicers and stuff like that. So we can figure out when the magic of DAX and Power BI just works, where you slice and dice and you just seem to get the number by some incantation. We're going to see how that incantation works, right? Now, if you're thinking to yourself, Brian, I am not a database person, I am not a programmer, good, right? I come from an Excel background. I don't have a programming background. Excel is the way that I think, and so this presentation is designed for you. It might be on the higher end of the technical stuff that you've worked with before, but I'm tailoring this for Excel folks so that you can hear in language that I hope will make sense to you how DAX works and be able to sort of reproduce it in your head as you write stuff. So we'll see how we do. Okay, so in the first section, right, we're going to kind of do the same thing twice. In the first section, I'm going to introduce the concepts at a slightly higher level, and I'm just going to show a couple pieces at a time. Then after I've done that, I'm going to circle back and do the exact same thing again, but I'm going to do it as what I've been calling a DAX sketch, where I keep all the pieces of the board on the screen at once so you can really just sort of see everything, okay? So we're going to do the exact same thing twice so you could really get a sense of how it works. Okay? All right, so we're going to learn a couple things here, right? 1, 2, 3, 4 of them, 4 big takeaways, right? And if you don't know what these takeaways are yet, good. I haven't done the presentation yet, unless you watched it last week. So these should be confusing right now, right? First confusing thing right now. Aggregations work with copies of the raw data. Ooh, that's interesting. Confusing thing number 2, relationships allow for a mega VLOOKUP, which is going to add columns for filtering to the copy. Confusing thing number 3, filters in DAX are tables whose rows act as a list of values to keep for a given column. And lastly, confusing thing number 4, the final sum or min or max or average is going to get done on the filtered copy. Okay. Again, these are confusing right now. Hopefully by the end, they'll make a bit more sense. Okay. So let's talk for a minute about the demo data that we're going to be working with. So we're going to have 2 Excel files that we're going to imagine working with. The first one is a sales transaction workbook for a fictional restaurant that if you've watched my videos before, you're probably tired of hearing about, but I'm too uncreative to build a new one. So for these sales transactions, we're going to have our 1, 2, 3, 4, 5, 6, 7 sales transactions for our fictional restaurant, right? And for each sales transaction, we're going to have the shift that it happened in, whether it happened at lunch or dinner, the number of stuff that a person bought for the quantity, whether they bought 2 of something or 1 of something or 3 of something, the sale amount, how much money we made, and lastly, the dish, whether the person bought pasta, burger, and the one person down here bought salad, right? So normal stuff that you'd see at a restaurant, okay? So that's our first data source. We got another one though. Over here we have, or we can imagine, a different Excel workbook that's got 1, 2, 3 rows in it. And here we've got lookup information for our dishes, right? So we've got the 1, 2, 3 dishes that we sell at our restaurant, pasta, burger, and salad. And for each one, we've got some information. We've got the type of dish it is, whether it's a regular dish or our house special. The burger is the house special, right? Whether there's a gluten-free option. So with a burger, we'll wrap that sucker in salad. You can have it that way. And for the salad, we just don't put croutons on it. So those are both gluten-free. The pasta, there is no gluten-free option because it's pasta. It is gluten. That's what it is, right? Notice we also have this last column over here with the cost for each one of these items. How much our estimate is for how much it costs to make it, okay? Now, this is the two workbooks that we're going to be working with. And Excel folks might be thinking to themselves intelligently, hey, I see that there's a dish column over here. And there's a dish column over here. In regular Excel land, what would you do? You would go reach for your VLOOKUP, right? You'd say, hey, I want to go VLOOKUP. I'm going to take the dish over here and look up this information over here. We're going to do something pretty similar in DAX. So if you had that thought, good for you. That's the right thought to have. Okay. I'll pause. Any questions about my fictional restaurant and how it is that it stays in business so far? I'll grab a sip of water. So far, so good. Okay. Okay, so that's our data. So let's imagine that we use the Get Data button in Power BI to go load this data into Power BI. So we hit Get Data, right? We go find those workbooks and we load them. We load the sales table. There it is, loaded into Power BI. And there's the dish table loaded into Power BI, right? 7 rows and 3 rows. Okay, not too bad. So let's take those same tables. I'm just going to like move them up to the left corner a little bit so we can focus on them. We're going to take those two guys right there, right? There we go. So this is our data model. This is the raw data that we're going to give to the DAX engine to do summarizations, to do aggregations and stuff like that, okay? So again, we got our sales table and our dish table. Now, if you've used Power BI before, you're probably familiar with the concept of relationships. So the idea with a relationship is that you would navigate over to the model viewer, which sometimes I refer to as the International Space Station, where you got all your tables and you draw little lines between your tables to create connections between those tables. So in this example, because we have a dish column in sales and a dish column in dish, we would drag dish from here and drop it on dish there, and we get a relationship in DAX. And it would look like that, right? So you do this in Power BI so that you could summarize the numeric values of this table down here by all the categories of this table over here. So you could summarize these columns by the categories in this table. That's sort of why you would do it, okay? So when you do this, what it creates is a relationship, and there's sort of two ways you could describe it. The more technical way that folks have probably heard before is a many-to-one relationship, which is a pretty good way of describing it. By that, we mean here in the sales table, we can have multiple dishes, right? Because a person might buy a dish on more than one occasion. Here, pasta shows up not once, but 1, 2, 3 times, right? As opposed to the dish table, where by definition, this is 1 row per dish. So every dish appears 1 time. So this is the 1. Every value here for dish is unique. And here for dish, there's many instances of it. That's where you get many to one. Now, that's technically accurate, a very good way to describe it. A good way to think of it, especially if you're an Excel user, is we are creating a lookup relationship from sales to dish, right? If you are an Excel person, you're very familiar with the VLOOKUP function. And so what we're doing is we're giving away for Power BI, the DAX engine, to take all the values in this row here and look up attributes of the different dishes. So for any given sales transaction, I can look up what type it is, whether it was a gluten-free dish or not, and what the cost per dish was or not, right? Okay. Okay, so ignoring how this works for a minute, I want to point out that, again, creating this relationship is what allows us to magically drag and drop columns from the dish table onto slicers and have them affect aggregations on the sales table. That's the effect we're going after, but we want to learn about how that works. Okay. One more side note. From the sales table, we can look up information on the dish table. The opposite is not true. If we know what a dish is, I can't go look up the shift, right? Because a particular dish might have been sold for lunch or it might have been sold for dinner. We might have sold 2 of them, then a different time we might have sold 3 of them, right? So the lookup relationship only goes in one direction. So here from sales, I have a lookup relationship to dish. If I've got a sales transaction, I can look up dish information. The opposite is not true. If I've got a dish, I cannot look up sales information. Okay, look up in one way. All right. So we got our tables. I want to spend another minute talking about column names. If you load data like this into Power BI and you go to the left-hand side and click on the little button to look at your table, your data as you load it, it'll look like this. And the column names are these short column names, which is good, but it could be a little bit misleading, right? So when you look at your model tables in Power BI, it shows you the shortened column names. However, the real names for columns are considerably longer, right? They look like that. So you might think to yourself, oh, the name of this column is shift. Yeah, that's kind of like the shortened name of it. The full name of this column is sales shift. So each column, the real name has both the table it came from, right, sales or dish, and also in the little square brackets here, sort of the local short name of the columns, right? In the same way that you could call me Brian, I don't know who you're talking about. My full name is Brian Grant. So the full name of these columns are these longer ones up here. The fancy term for those is the fully qualified names. The reason I bring it up is those are the names that you will use in your DAX formula. So you might think, oh, I should just type in the name quantity. When you type in names of columns in DAX, they're going to look like this, right? And when DAX talks to itself and is talking about different column names, these are the way that it describes column names to itself. Okay. Pause. Any questions so far? Feeling pretty good? Okay, we keep on going. Okay. So now what I want to do is imagine that we took this data that we loaded, we created the relationship, and we're going to say that we create a measure called total sales, which has a fairly simple formula. So the name of the measure is total sales, and the formula is the sum of the amount column in the sales table. Or said otherwise, it's kind of like summing up that column right there, right? So we go ahead, we add that measure, we drop it onto a card, we get 110 bucks. And if you were to get your calculator out and add all these up, you would see it is indeed $110, right? Then we can imagine we add some slicers, right, for our different types, whether it's the house special or regular dish, and also the gluten-free options, whether it's a gluten-free dish or not a gluten-free dish. Let's imagine further that the user clicks on regular, and the number drops from 110 down to 62. Now, this is expected. It's what we want because $62 is the sales for just the regular dishes, right? It's great that we got the right result, but how did we get it, right? Other than just saying, trust me, Brian, these relationships allow that to work. What mechanically happened so that we got that right, correct, magical number? Let's see. Okay. So when we perform the sum of the sale amount column, we're going to have 1, 2, 3, 4 steps. Right? 1, 2, 3, 4. The first step is we're going to get a full copy of sales. The second step is DAX is going to perform the mega lookup. The third step is it's going to apply the filters. And the fourth step is it's going to aggregate the sale amount column in this new copy that has had the mega lookup done to it and filters done to it. Now, if you're thinking to yourself, Brian, I think I may know what you're getting at, but I think I've seen these called different things before. These are the names that I think are good for Excel folks. You may have heard other names before. So when we say get a full copy of sales, you may have heard the term table value before. If you've watched my videos a lot, you may have heard me say a temp table, maybe even a temp table of native columns. Those are all correct. If you're an Excel person, though, just think of it as a copy. If you're a programmer thinking to yourself, Brian, is it really a copy or like a view? Think of view or a logical copy. Again, Excel folks, just think copy. Okay. Then we're talking about the mega lookup. If you're thinking to yourself, hey, I've heard of table expansion before. Is it a similar concept to that? It is. You may have heard it called a left outer join before. Those are both correct. And when we're applying each filtering table, if you've heard the term natural semi-joins before, good for you. That's exactly what we're going to talk about. If you haven't, you don't need to understand any of these more technical terms, right? Okay, so that's what's going to happen. Let's go watch it. Let's go watch it. All right. So the first thing to know is DAX always works with copies of data, right? If you prefer the term logical copy, that's fine, but it never works with the data in its raw form. It always gets a new object to work with. And we're going to think of this as a copy, right? So the first thing the sum does is it's going to get a copy of this sales table over here, right? Just like that. So this is our copy, right? This copy of the table only exists in memory, and it will only exist long enough to come up with the correct number, okay? DAX always works with copies. So that's part one. So now that we've got our copy, what we need is a way to apply any related filters. So we've got a filter over here on regular for our dish type, right? How are we going to apply this filter to this copy over here? Well, that is where the mega lookup comes into play, right? With the sales table, I told you before, we have a lookup relationship to dish. That means if we've got this copy, we can go look up all the values of dish, right? With a VLOOKUP, you look up one cell and one column at a time. With the mega lookup, it goes and grabs all these columns at once, right? And it looks like that, right? So DAX took the copy and added all these columns from dish, right? Through the what we call the mega lookup process. This is for SQL folks a left outer join. And for the very advanced DAX folks, if you've heard the term table expression, that's the name that you have for this thing here, because it's almost like the table is blown up like a balloon, right? Any relationship, we're going to add all those columns on here. Now, if you'll notice in our copy, we have 1, 2, 3, 4, 5, 6, 7, 8 columns. And the names of the columns here are the full names from their source. So you could tell by a column not only what the little local name is, but which table it came from. These over here came from the sales table over here. These columns came from the dish table over here. Okay. Okay, I'll pause. Any questions so far? This is still working good for folks? Groovy. Okay. So the mega lookup goes and adds all those columns, right? Okay, so in this example, we have one lookup table, the dish table over here. So we added all the columns for dish. If we had, say, 6 lookup tables, this mega lookup would go grab all the columns from all those tables. And the resulting copy would be very, very wide, and it wouldn't fit on the screen, which is why I'm only showing you one of them. Okay. All right. So now we got our copy, and we performed the mega lookup on it to go grab all that extra stuff. What are we going to do with it? Well, now we got to go apply some filters, right? Because we're hoping to get to that $62, and right now we've still got too many rows in here. So here is where we come to the next confusing bit, right? In DAX, filters are tables. So when I click on this slicer here for type equals regular, it produces a filter that looks like this. It's one row and one column, and it indicates what values do we want to keep and which column do we want to keep them on, right? So this is very confusing to humans. In fact, it's very confusing even to like programmer type people. You're used to hearing things like where type equals regular or something like that. It's unusual to think of a table as being a filter if you are a human. However, if you are a database, this not only makes sense, but actually runs faster. The reason DAX operates in this way is because it has to do things so quickly. Because keeping filters as tables like this is so much faster, that's the way it likes to talk about them. Okay. All right. So now we've got our copy down here, and we've got our filter. Let's go see how the filter actually filters. Okay. So what happens is DAX first checks to see if the filter has any common columns with the copy of the table we're working with, right? So we say, hey, we're going to look at this filter table here. Does it have any common columns with this one down here? Well, nope, that doesn't match, that doesn't match, that doesn't match, that doesn't match, that doesn't match. Hey, yeah, that one matches right there, right? So this has a common column with right there. So what does it do with it? Well, it's going to focus on it first. And then what's going to happen for filtering, DAX is going to say this value here, this is going to act as a list of values to keep, right? So for any row where the dish type is regular, we're going to keep those rows. And any row where it's anything else, we're going to get rid of it. So we're going to keep the regular rows, and we're going to get rid of all the house specials, right? Called a semi-join for SQL folks. Okay, so we're going to go ahead and get rid of those 1, 2, 3 rows like that. And now we've got that filtered copy of the table that we're going to work with. Okay. So we're almost done at this point, right? At this point, all we got to do, this is the least interesting part, is the sum function is going to sum up the sale amount column. And it's going to sum it up in this copy here. It's not going to sum it up in the original table that you loaded from Excel. It's going to sum it up in this copy that's had all these columns tacked onto the side of it and all the filters applied, right? And when we do, we notice if we add 20, 10, 12, and 20 together, we get 62. And that is how the basic aggregations work inside of DAX. Okay. So let's go through those steps again real quick. Okay. So we got a full copy of sales. We took this, we got a full copy of it. We performed a mega lookup. Any table that had a relationship to that copy, we go ahead and tack all those columns onto the end of it. And then we say, hey, every single filtering table that we've got from a slicer or anywhere else, right? We apply those right? And we say every value in that filtering table, that is a row that we want to keep. That reduces the number of rows to just the correct amount of rows. And then when we're all done, we aggregate the sale amount column in that new table right there, just like that. Okay. Okay. These have fancy names. There they are, right? Okay, so we're about to see this exact same thing from beginning to start again if this is a little fuzzy in your mind. But before I show it to you again, are there any questions about what we've seen so far? Or questions about stuff in general? Life, when
Not
the
seeing
pandemic's
questions
going
in the chat. But yeah, anybody going once, going twice?
I just have like a really simple, like basic question.
Perfect.
So
Perfect.
is DAX like essentially just the language that's being used to create measures?
Uh, they're related. So I would say that DAX, so when you write a measure, DAX is the language that you are writing in, right?
Right. Yeah.
And measures are all about aggregations. And so the DAX
Mhm.
language is about kind of doing these kind of aggregations. They can get really fancy or they could be kind of
Mhm.
simple like this.
Okay.
Does that
But
help a little bit?
yeah, I just am trying to like m make sure that I'm on the right page. So basically, every time I write a measure, I'm using DAX, whether or
That
not
is
I know it.
absolutely correct. It looks like
Okay.
Excel. It's designed to look like Excel, or
Okay.
it's designed to look like I don't care as long as I write the thing that gives the right number. I don't care. The
Okay.
technical name for what you write though is DAX. There's a
Okay.
couple other things you could do with it, but mainly you're writing measures. When you say I'm working with DAX, it's mainly writing measures.
Okay.
Does that
Awesome.
work good? Okay.
Yeah, yeah, that's perfect. Yeah, thank you.
Perfect. And I'll say there's another language called M, and when you hit the big get data button to load data and it opens up that second window, in that second window, you're actually clicking on a button and it's writing in a different language called M. So M is all about
Oh,
cleaning up data, right?
okay.
And it's very flexible but very slow. Then once you
Okay.
load the data to do the aggregations, DAX is very, very fast, but less flexible and more confusing, right?
Okay.
Which
Okay, for
creates a
sure.
little confusion. Yeah.
Okay. Thank you.
Perfect, perfect, perfect. Any other questions out there? Any other questions out there? Okay.
I think we had a good comment like how DAX is converted to M in the advanced editor. And that's how they're so related, just as you mentioned.
Yes, that's correct. Yeah. Okay, so let's pop over. Let's do this whole thing again from the beginning so we could see how these basic aggregations work, right? Okay. So we're gonna do this one more time. Now, this time when we do it, we're going to try and keep all the relevant information on the page at the same time. So I'm not just going to show you two things at a time. I'm going to show you all of it, just so you can see the whole enchilada, right? Okay, to do this, I'm going to use what we've been calling a DAX sketch. This is sort of a method that we've built here at SkyPoint to illustrate DAX so you can keep track of it. So if it looks like I've done this kind of thing before, I have. There's other videos like this, and this is an example of it, okay? All right, so let's do that whole thing again, but as a DAX sketch. So, hey, there's our data model. We already talked about this. We've got our restaurant that will soon be going out of business with its 7 sales transactions. We have all the dishes over here, right? And we have a lookup relationship between sales to dish, or a many-to-one relationship, if you want to call it that, okay? We have that same measure, total sales. It's the sum of the amount column in the sales table. And lastly, we're going to imagine that same visual. We're getting total sales just for regular dishes, 62 bucks, 62 bones. Okay. So when we imagine DAX, when I do it as a sketch, I draw this little frame down here, right? This is technical term for this is the filter frame. You can imagine DAX is almost like not a card game, but a game of tables, right? And so this is the place where all of the tables will be played, just like cards are played on a cardboard, right? Or a card table, I think more accurately. So before anything will happen with this formula up here, DAX has to set up the game. There's a few things that need to be in place before DAX can run this bit right here, just like setting up a board game, okay? And one of the first things it's going to set up is all of the initial filters. So any filters that are in place, DAX has to put up here in the top left-hand corner. Those are going to be important, right? So to set things up, it's going to add a filter for regular, and it's going to put it up here, and the technical term for where it's putting it is the filter context. So what can we imagine it looking like? Kind of like this. So we've got this filter up here for regular. we're going to go ahead and add one filter in our filter context for dish type equals regular. There's our filter right there. This is what's going to do the filtering for us in a minute. Okay, so now the game board is all set up, right? DAX is going to start running that formula, right? So let's go ahead and see what this thing does. So it's sum of sale amount. All right. So down here, just to help us illustrate it, we're going to put sum of sale amount. This is the thing that's going to happen. I use this little camera icon up here to indicate functions that go and grab data from the data model. Because this is going to get that copy that we were talking about earlier, I use a little camera right there, right? Okay. So what's involved in running that sum function again? I forgot already, Brian. Here, let me help you remind you, right? So with the basic aggregation, we're going to do 1, 2, 3, 4 things. We're going to get a full copy of sales, perform the mega lookup, and apply each filtering table. And then when we're all done, we're going to sum up that sale amount column in the new thing, right? Okay, let's do them one at a time. We're going to start with step 1 because it's less confusing if you do. So we're going to start by getting a full copy of sales, right? We're going to get a full copy of sales because eventually we're going to need to sum up the amount column, which is in sales. So we got to start with that full copy of sales. Start with that. There's sales over there. We make our copy of it. Hey, boom, there we go, right? There's our copy. Again, you may have heard me call it a temp table before or a table value. Copy is the right way to think about it when you're starting out, okay? So that's it for step 1. That was easy. Now we're going to perform the mega lookup, right? Because this table sales has a relationship with dish, we can go look up all these values and tack them over here on the right-hand side, right? So because we have that lookup relationship, we can look up and go grab those columns. So now our copy doesn't have 4 columns, it has 8 columns. And it's got these extra columns from the dish table. By adding these, that's what's going to allow this filter thing to work here. By the way, you may have heard before names for these different kinds of columns, whether they come from the original table or this table over here via the lookup, right? So for folks that have heard this before, these ones that come from the original table are called the native columns, right? Because they're from the sales table. These columns over here that we got as a result of the mega lookup, those are called related columns. The reason that is meaningful is there is a function in DAX called related that allows you to access the values in these columns over here. So you can actually do stuff with them if you want to, okay? Okay, so we've got a full copy of sales. We performed the mega lookup to go tack on these extra columns there. Now we're done with step 2. We got to move on to step 3. We're going to apply each filtering table, right? Well, how's that going to work? Well, how many filters do we have? Actually, let me sort of write out the steps here before we do that. So there's kind of like 2 steps for filtering, right? For every filter table in the filter context, we've just got the one. If there were multiple, we'd do this a couple different times. For each one, we check for matching column names in the target table, and then we use the values of the filter table as just what to keep, right? So let's see how that works. Right, so we got the one filter right there. We're going to do it for that one. We're going to start by checking for matching column names in the target table. So this filter is on dish type. Is there a dish type in this table over here? Well, not in the native columns, but over here in the other columns, yeah, right there. We got that column right there. So we're going to sort of hone in on it. What is DAX going to do with it? DAX is going to say, hey, if I've got a filter that looks like this, I just want to keep the values that are regular. If they're anything besides regular, like say how special, we're going to get rid of them. So we're going to keep this row, this row, this row, and this row, and we're going to get rid of that one, and that one, right? Let's see, so there we go. Those are the rows that we're going to keep, and the filter is going to go ahead and knock out those other columns, right? Again, for SQL folks, this is called a semi-join, but you don't really need to know the technical name for it. All it means is whatever the values are in this table right here, that's what we're going to keep, okay? All right, now we're all done. We're all done with step 3. If there was more than one filter, we do that exact same process for the other ones too. The order ends up not mattering. Now we do the last part. Which is in some way the least interesting, but probably the easiest to follow. Now we're going to sum up that sale amount column in this table down here, not this one up here because it's not filtered. And this copy down here, we've got just the right rows that we want to look at. And so when we sum that up, we take 20 plus 10 plus 12 plus 20. What does that equal? That equals 62. And we get our 62 bones right up there. And that is how DAX arrives at that number. Okay. And that is how basic aggregations work inside of the DAX language. It doesn't matter which aggregation you use. You could use sum, you could use min, you could use max, you can use median. They all work the same way. The only difference is what they do with that finished column when we're all done. They all get that copy, perform the mega lookup, apply each filter, and then when we're all done, that's when they do the aggregate on that copy. And that's it. You guys know a ton about DAX now, even if you didn't think you would at the beginning of this presentation, right? So if this seems a little heady, it should. It's a little tricky. However, these are really advanced concepts that we're going over here. This is stuff that a lot of like folks that study DAX don't get to for a while. My hope is that by presenting it this way, they're less scary and you can understand them. They're not difficult. They're just difficult to read about in prose. It's all just tables kind of V-looking onto each other and doing keeps and stuff like that. It's all not that difficult. So I've got some more stuff, but I'll pause now that we've gone through this twice. Any questions about what we've done so far?
Yeah, Brian, I have one question.
Yeah, sure.
Yeah, let's say we had a much more complex data model, like if we had like 10 other dimension tables that we had linked together. Would it be building this mega table, this mega lookup for all of those? Or is it okay? So the more complex your data model, the more it's having to do.
Yeah, and the reason it's called the word expansion, you can think of it blowing up like a balloon, right? So if I start with, let's say my fact table's got like 5 columns in it, and all it is keys, but I got like a whole bunch of dimension tables hanging out here. It keeps getting wider and wider and wider and wider, filling up like a balloon, right? A question that I sometimes get is, that seems like that would be terrible from a performance point of view. What were they thinking? The answer is that, and I'll get a little heady here, you don't actually have to materialize all those columns. We're just sort of adding them logically. And so there's a little bit of a difference between what we are asking DAX to do, which is what I'm describing right here, and what DAX ends up doing. So DAX will be smart enough when it reads its own code to actually simplify the columns that it adds and where it expands and whatnot. But in terms of the right way to think about it this way. I want you to think about, when you do that, it goes and grabs all 100 extra columns from all those dimension tables. Does that make things better or make things worse?
No, that does. That's very helpful. So if we weren't doing any filtering on those other items, it wouldn't necessarily have to do all the work, but it is kind of keeping track of it.
That's right. And don't second guess yourself by trying to track what it's doing. Let it do the optimization part, right?
Yeah, it's very good at it. So
it's very good at it. There's a whole other thing about this thing called many-to-many relationships, where you use this blown-up version of the table as a filter inside a calculate. Sorry, I'm getting a little ahead of myself here. And when you see it written down, you go, oh my God, it's baffling. I don't even get it at all. The reason it works is because when we take that little teeny tiny fact table, it grabs all these columns from all the other dimensions, and you could use it as a filter, because when it does that matching, it's got all those columns in there that work as valid filters. So keeping track of, it just grabs everything. That is the right way to do it, particularly when you're doing like, if you do like a sumx function, you can use the related function. I'll show you this in a second, where you can go grab those values from those extra columns. It's very helpful in your head to just think about them all being there, right? Because logically they are. Did I make it better or make it worse?
No, that's great. I really appreciate it. Thank you.
Yeah, fabulous.
And I see Lee also posted a question. Any difference in this process for implicit measures?
Oh gosh, I was wondering why I couldn't see anything in the chat windows, because I didn't scroll down. No, it works the exact same way. The measure just doesn't have a name. Yeah, it works the exact same way. So if I just took the sale amount column and dragged it onto a card like that, it does the exact same thing, right? You just don't officially have a name with, an official name, but the mechanics are exactly the same. No difference, right? Let's see. Okay, good. Is there any other stuff I skipped? I'm sad that I didn't see all that stuff in the chat. Let's see.
Visha, related tables would be used when there is an inactive relationship. Oh, I think that was more of a comment than a question.
Yeah, so we'll get into related tables. We'll focus on related rather than related tables. This is supposed to be an introduction to this stuff, so I don't want to get too far ahead of myself here. But the related function I will show you in a second, okay? So before I show you a couple of little extra content, other questions about what we've seen so far? Brian, can you show me that piece again?
We get extra content.
We get extra content. I did this exact presentation for the SF user group last week, and I've done a lot of presentations over the years, and every single time I think to myself, I'm never going to fill 45 minutes with this presentation. And every single time I go an hour and a half and I cut out like without going through all my stuff. Last week was the first time I got done in like 40 minutes, and I'm like, so what do you guys want to talk about? So I added some extra stuff so you guys have stuff to see, right? Thought ahead. It's the first time it's ever happened. Second, I guess.
I'm
Okay,
sure
let's go
people
see
can
some bonus
appreciate
stuff.
having some time for questions and stuff, Brian. So,
Oh yeah, we got time for Q&A, but before Q&A,
yeah.
well, before Q&A, let's do some takeaways first, right? Stuff that you might not guess if you're just learning DAX for the first time. These aggregations and really anything in DAX is working with copies of the raw data. Logical copies if you prefer it, table values if you prefer it, but you're not working with the tables directly. You're always working with sort of a copy, right? The relationships allow for that mega lookup, which is going to VLOOK up all those extra columns into your copy of the table. And by tacking them on, the filters have something to grab onto. Speaking of those filters, the filters in DAX are tables whose rows act as a list of values to keep. And by adding these extra columns here, they can kind of grab onto them and just keep the values that we want. If we've got this filter for regular, it's just going to grab all the regular rows and get rid of all those extra rows that we don't care about. And that final sum or min or max or median or whatever the heck it is, that's going to work on that filtered copy, right? Not the original that you loaded from Excel or wherever you loaded it, the copy down here that's been both expanded and filtered down. Okay.
Can I
Yeah,
ask
yeah.
a question about that, the copies? So,
Yes.
like, am I able to actually see those copies when I'm working in a Power BI when I'm like building it out? Can I see them anywhere? Because I don't really recall seeing copies of them of any of my tables.
So I have an answer for you that I wish it was a different answer. You can't see them directly, right? And
Yeah.
it's a bummer because it'd make everything
Okay.
way easier. It would create way less confusion when learning DAX, right?
Okay.
That's a really good question. I was at a conference 7 years ago at this point, up in Seattle, and somebody, I think they asked Alberto, one of the SQL BI guys, like, hey, is there an evaluate formula button like there is in Excel? Like all the Excel folks like me were like, yeah, where's the evaluate formula button? And he kind of was like, no, there's no evaluate formula button, which is too bad. It makes sense if you think about it, because the data is so big and so voluminous. What would it even show you? If you got my dummy data here where it's like 7 transactions, yeah, you could see that. But if you got like 34 trillion rows of data, what would it even show you, right?
Yeah.
So that's the bummer. There are some, shameless self-promotion. I got some videos and our YouTube channel that I'll link to in a second. This is kind of all I've done for the last couple of years is show these kind of things. Terminology changes a little bit, but it's a good excuse to see some of that stuff. And there's also some tricks you could do inside of DAX to kind of draw the tables and sort of see them a little bit. So if we have time, I can even show those to you as well. So a bad answer followed by shameless self-promotion and maybe a good answer snuck in there as well. Does that work for you?
Yeah, thank you.
Yeah, great. That's exactly, yeah, Paul's got it. If you do DAX Studio, you can see the intermediary steps, which was my big trick. But yes, right on. Yeah, that's the way to do it. Okay, let's see. Why does it matter? I said I was going to talk about it, and then I didn't. So most users quickly focus on the raw tables in the data model because that's what you could see in the program. That's what you were just asking about. Everybody does it. I did it, right? You load the data into Power BI, or if you've been doing this long enough, you load the data into Excel, right? The tables you can see are these tables right here. So when you think to yourself, oh, DAX is working with tables, your eyes go, oh, yeah, it's like these. That makes sense. That's the right thing to do naturally as a human being, unfortunately, right? DAX doesn't do anything with these originals. It always works with these copies, right? So getting good at envisioning these copies is, if you were to ask me honestly, I think it's probably the single most valuable skill in DAX. The sooner you could see these copies of the tables and how they're working and what they're doing, the DAX language becomes infinitely easier. And if you can't see them, it's very, very difficult to look at a block of DAX code and sort of reason through what it's doing. But if you look at that same block of code, and in your head, you see the little fuzzy rectangles corresponding to, oh yeah, it's getting this table. Oh yeah, it's doing with this with a table. Oh yeah, it makes this summation on that copy of the table. The sooner you could do that, DAX becomes I don't want to call it easy, but less unbelievably painful, right? I call this skill table vision. I've talked about it before. If you just knowing to think about these copies will help you get there. And also I got the videos, those help as well. And there's some other stuff that you could do for it. As we said, DAX Studio is a great way to sort of see some of the intermediary steps. Okay, so DAX is a much simpler language than most people think. It's actually really, really simple. It's like got as many rules as chess. But you can't understand it until you can start to see some of these tables. That's why I'm showing it to you. Okay. Okay. Extra stuff. Extra stuff. Oh, here we go. Let's see. Extra stuff. Hey, Brian, those filters, are they always like one row by one column, or can you have like multiple rows in there? Hey, you can have multiple rows. Let's imagine we got a slicer like this, where the user clicks on burger and salad. What does that filter look like? Looks like that, right? It's still one column because it's on the dish column, but here we're saying we want to keep burgers and salads and get rid of anything else. So what does it do? Well, we're allowed to keep any row where the value is burger or salad. So we're going to get rid of the pastas. Boom, there they go. The copy filters down to that, and then we would do the aggregation with just the burger or salad rows, right? That's not too bad. The one that's a little bit trickier that I get asked sometimes, hey, can filters have more than one column, right? Yeah, they can. So let's imagine we click on this. The user twirls open dinner, and they want to see pasta dishes for dinner, and they twirl open lunch, and they want to see people that ordered burgers for lunch. Why? I don't know, but let's just say they did. What would this filter look like? This filter would look like that. Again, it's a table, right? The filter is on two columns, the shift column and the dish column, or to be more accurate, sales shift and dish. So what does this do here? How does this behave? Well, what we're going to do is we're going to match and we're going to keep the combinations of these values. So we're not just going to keep lunch and dinner, and we're not just going to keep burger or pasta. For a row to get kept, right, in our copy here, it's either got to be the combination of burgers for lunch or the combination of pasta for dinner, right? So we're just going to keep the rows where somebody either ordered burgers for lunch, or somebody ordered pasta for dinner. Everything else goes away, right? And lastly, we get those rows right there. Okay. Questions about that? Or the last one? Smash that subscribe button. Smash and subscribe. If you don't smash the subscribe button, YouTube doesn't know that you did it.
We can be gentle. Let's be gentle and soft and kind and caring.
2023. It's been a long couple years. Please be gentle.
Exactly.
Hey, how do those number range filters work, right? What if I do something like this, where I say in the amount column, the amount of money we made, I want to go from 10 to 20. What does that filter look like? What DAX does is it builds a table of all of the values that we ever sold that were between 10 and 20. So for all our sales transactions, some of them we made 10 bucks, some we made 12, some we made 16, and other ones we made 20. These are all the values in our original table that are between our two boundaries right here, right? And what does DAX do with them? Well, it just keeps the rows that are 10, 12, 16, or 20, or all the values between 10 and 20. Keeps those right there. Hey, Brian, that seems bizarre. What if I've got like a column that's got like a whole bunch of numbers in it? Does it really create all those numbers as a table, even if it's really, really big? Yeah, it does. It might seem like it's really slow. Don't worry, the smart people at Microsoft have built it to be really, really fast, but it really does build that big, giant table with all those values in there, right? Okay, I think I got one more question that I made up myself. Hey, Brian, can I sum up more complicated stuff? You can. What do I mean by that? So let's sort of rewind a little bit, go back to our original example. The sum of the sales amount. You guys remember this, where we made that $62. What if I want to do something slightly more complicated? What if instead of the sales, I want the total cost? Well, there's no cost column, right? I've got an amount and I've got a quantity. I have a cost per column if I were able to, for every single row, take that row's quantity and multiply it by cost per. For each row, I would get the cost for each transaction. And if I could sum those up, hey, I'd have the number I needed. You could do this with a calculated column. If you're thinking that, you absolutely could do it. But you don't have to. There's another way in DAX. Let me show you that other way. We're going to take this here and we're going to rewrite it like that. Total cost, sum x. Ooh, the x iterator functions. These can get rather complicated, but they don't have to be, right? So sum x says, I want to go perform some more complex calculation. And I want to draw your attention to the second argument of sum x, this guy right here. This right here, argument 2 of sum x, or any iterator, is what I call the per row formula. It is the formula that will run once per row. That's where it gets the name, right? So whatever we type here is going to run for each and every row down here, right? If you would prefer a fancy, very technical sounding name, you could call it the multi-row contextualized sub-expression. I'm not going to call it that. I'm going to call it the per row formula because that actually, sounds like it means something. The formula that we run for every single row. Okay. Okay.
Really
question,
quick, Brian. Just Scott was wondering, do most or all the functions have the same kind of steps that DAX kind of looks through? The copy table, the mega lookup, etc. Or is this only specifically for writing like sum x or calculate?
So for all of the basic aggregations, all the ones that like you think of in aggregations in Excel, things like sum or average or min or max, those all work that exact same way with that exact same 4 steps. The only thing that changes is the very 4th step, the aggregation. It changes. If you use sum, it sums stuff up. If you use average, it averages it. If you use min, it gives you the biggest value. If you use max, it gives you the highest value. So that's all the changes with those. Otherwise, they're exactly the same. With other functions in DAX, though, you have to be more specific about it, right? And to be less cryptic, here in my sum x function, I have to tell it which table, which copy of a table, to be specific, I want to perform this per row formula for. So here where I type in sales, right? This is actually the bit that does the first, if I've got the 4 steps, it does the first 3 of them, right? Here where I type in sales, it grabs the copy, it does the mega lookup to add all the columns to it, it filters things down, and then I pass into sum x where it does the slightly more complicated thing of running a per row formula for each row. So not all the functions have the same steps, but most of the time you end up getting one of these copies. It would be very unusual to bother loading data from Excel or SQL or whatever and not write a measure that gets some sort of copy of original data. Otherwise, what are you going to report on? I guess you could report on what the current date is, but if you're going to work with your data, you have to get some kind of a copy with it, right? And there's actually a couple ways to do it. The easiest one is just writing the name sales here, the name of the table like that. So the sum functions keep it real simple for you. You just type in one line of code. If you want to do sum x or min x or max x, you still have to tell Power BI or DAX what kind of copy you want, and that's what argument 1 is. So you still kind of have to do it. Okay. Okay. Did that make things better? Make things worse? Follow-up question.
Scott, feel free to come off mute if you want any more clarity.
But good?
I think to your point, Brian, it's mostly the aggregators, and I think that definition of what is aggregators? You just hit on succinctly, and Scott says, "Good, thank you." So
you got it. Oh gosh, there's other complicated stuff I want to show you, but I'm going to be good and keep it nice and scoped. Okay. So hey, I was saying before, with sum x, it runs a per row formula. What does that mean? Well, this is a formula, and it's going to run once per row. So let's see what that looks like. Okay, so here we get our copy of it, and sum x runs this formula for that row, that row, that row, and that row. And so here for the first row, it goes and gets the sale quantity, which is 2, and then it gets the cost per, but it gets it from these related columns. So if you want to sort of cross through this portion of the table and go over to those columns that we got from the mega lookup, that's what the related function lets you do. It says go get a value in the current row, but it's one of our related columns. And so that grabs dish cost per, that grabs 4. So 2 times 4 is 8, we get 8. 1 times 4 is 4, so we get 4. 1 times 6 is 6, so we get 6. And lastly, 2 times 4 is 8, so we get 8. And what does sum x do? Which column does it sum up? Well, it doesn't really sum up one of these columns. It sums up these things and numbers over here, which are kind of like a column, right? These numbers that we produced by running that formula once per row. Right? Sums those up. What do we get? 26, which, by the way, is the right answer. Okay. So, yes, you could do more complicated. You do even more complicated stuff, but that's an example of sort of middle complicated. We're done, folks. You made it. Thank you guys so much for joining me. If you liked it, you could check out the SkyPoint YouTube page where I got a bunch of videos, including me making funny faces right there. And on that SkyPoint page is my Elements of DAX series, where you can see a whole bunch of videos kind of about this topic. So yeah.